Next question, how can we solve Riccati equation? And this one is more difficult to solve because we have quadratic terms here. The second order term, the second power term there. So for this kind of equation, there isn't any analytical solution method. So what we need to do is to use ARE function. ARE stands for algebraic Riccati equation. And for the equation here, if we know how can we enter A, B, C matrices, then we can solve the problem by coding ARE function and find the result directly. So this is the way to solve the original Riccati equations. You do not have to know the details inside the ARE function. What you need to do is how to code the ARE function and find solution to the Riccati equation problems. And here is an example. If in the Riccati equation we have A, B, C matrices, A, B, C matrices, and we can then code ARE function. Then we can solve the original problem using ARE function, and then we can find the norm if we substitute the solution back to the original equation. So this is the solution, and the error is quite small. And also, since this equation is a nonlinear equation or second-order equation, a quadratic equation, so there isn't any numerical, there isn't an analytical method to solve it. So this is the equation we get. Now let's recall the Riccati equation itself. And we know that there is a quadratic term, which reminds us that if we have an equation like this, for x, if x is x is a scalar, then there are two equations, x1 and x2. For matrix equations, how many solutions to the problem can be found? Since if we use ARE function, you can only find one solution. How can we find other solutions? This is the question, and I will answer this question later on in chapter 6, when we explain how to solve matrix nonlinear equations and how to find more than one solutions to this original problem. So I leave this problem open. So these are about the solutions of matrix equations. So the next topic here is nonlinear functions of matrix, or matrix functions. They are different. I will explain them later. First, we call nonlinear functions. We mean element by element computation. For instance, if we write x, we write a dot manipulation of x, we mean that for every value in x, we will take square. So this kind of manipulation. And also sin x. We mean that for every value in x vector, we will take the sin value. So these are the element by element computation. The other part is matrix function. So element by element computation, we normally have the functions like this, and we have many others. And I'm not displaying all of them. You can check Matlab commands. Absolute value of all the elements in the vector or matrix, square root, exponential, sine, cosine, tangent, and others such as INH or something like this. There are quite a lot of log. Others, such as log, I will explain the log function, which with the base of E and some base of N. And I have also explained how can we find the log of with the base of A like this. So we can have different kind of functions which can be coded in this way. B equals to function name A. And function name can be selected as one of these. And these functions are used as element by element manipulation in for the matrix A.